that project seeks to understand how plants make specialized metabolites or natural products. Now, you're probably wondering what the heck I'm talking about. So if you ever grow tomato plants, and you handle the leaves and the stems, you've probably noticed a pungent smell. Well, that's because you've disrupted these cells that are on the outside of the leaves and the stems. And inside of those cells are little factories that manufacture a whole bunch of different kinds of chemicals. These trichomes produce these chemicals almost certainly to protect them from insects. And so these chemicals are then in the cells. The insect comes along, crawls over, and maybe breaks some of the cells the way I do when I'm gardening, or when we're cooking, when we disrupt the trichomes on the surface of the leaves. And either the insect says, I don't really care about the way that tastes or smells, or it really finds it unpleasant and is less likely to stay on that plant, less likely to deposit her eggs, less likely to make a meal of the plant. What I'm really interested in is training people so that, because I'm not sure that I'm going to be able to do this in the near future, but to be able to actually start to understand the entire metabolic network, and how when you make a change in one part of the network, or the sun is shining more brightly and so metabolites flow in one direction, or now it's there's a cloud that's cutting out the amount of sunlight, so metabolism flows in another direction. Just what those different directions are and how they may be related to one another. Okay, so you might ask, well, who the heck cares about that? That sounds pretty esoteric, right? But one of the reasons why we care about it from an applied point of view, I mean, we care about it because it's interesting, but also because I think there are some really important applied dimensions. So, for example, when one goes and tries to metabolically engineer a plant, you say, okay, we want more oil in the soybean seed, or we want a different kind of cell wall so that it'll be more easily converted, the switchgrass can be more easily converted to cellulosic ethanol, okay? A lot of times, we say, hey, we know how this process works. I'm going to go in and I'm going to change this enzyme, I'm going to turn it off, I'm going to turn it up, I'm going to put in another enzyme in its place. And a lot of times, all sorts of strange things happen. Part of the reason is because these metabolic connections that we don't understand. So one of my goals for humanity for the future is for us to understand those well enough that we can actually go in and do predictive engineering of plants to make them produce what we really need or what we really want.